welcome to my channel. So today we are going to be looking at electromagnetic radiation in atomic structure. Okay, so we're going to cover some subtopics in atomic structure. Hopefully we cover a lot of topics. Okay, so we're going to start with electromagnetic radiation. So what is electromagnetic radiation? So electromagnetic radiation is just energy traveling through space in form of waves. Okay, so let me write it down here so that you see. So ER, we're going to abbreviate it as ER. Electromagnetic radiation is energy traveling traveling through space and form of waves. Okay, so electromagnetic radiation is just energy traveling through space in form of waves. Okay, so what are the examples of electromagnetic radiation that we can give? Some examples are microwaves, infrared, gamma rays, and so on and so forth. Okay, you can add with the ones you know. And so, what are the key ideas? What are the characteristics of an electromagnetic radiation? So, what are the key ideas? Okay, key ideas. So, um, every electromagnetic radiation has a wavelength. Okay, that's the first key idea. Wavelength. Okay, and the symbol for wavelength, we use the lambda. Okay, so what is this wavelength? Okay? What is the wavelength? So wavelength is a distance between two successive quests or troughs. Okay, so between, we're just going to say it is a distance between two successive peaks. Okay, between two wave peaks. Okay, we are going to say wave peaks, and these peaks can be either such as a trough or crest. So that's the wavelength. Okay, so wavelength is the distance between two two wave peak two wave peaks, which can be a trough or a crest. Okay, and it is represented by lambda, symbol lambda. So that's the one key idea. Every electromagnetic radiation has a wavelength. Okay. So second key idea is frequency. So every electromagnetic radiation has to have a frequency. Okay, let me write it, a frequency. So what is this frequency? So frequency is just how many waves pass per second at a certain point. Okay, so and it is represented by the letter V. Don't confuse it with the velocity. So V here represents the frequency. So frequency is how many waves as as at a certain point per second. Okay, so that's frequency. That's the second characteristic of electromagnetic radiation. And what is the last characteristic? So uh, the last one is that speed. Okay, they all have speed. They all have the same speed. Okay, and they move. They all move at the speed of light, which here is represented by the letter C. Okay, so the speed is always constant. So the speed is always constant, and it they all move at the speed of light, which is 3 times 10 to the power 8 meters per second. Okay, so that's it. So they have specific. There is a key idea in this, which we can represent as as the wavelength increases. So the wavelength we represented as lambda. As the wavelength increases, okay, as the wavelength increases, the frequency decreases and the energy also decreases. Okay. So as the wavelength increases, the frequency decreases, the energy drops. Okay. So which electromagnetic radiation has the highest wavelength and the lowest energy? So it is the example would be maybe a radio wave, right? Radio waves, radio waves. So radio waves have the highest frequency and uh, or has the highest wavelength, lowest frequency and energy. Okay, it's an example. And the one which has the highest energy and frequency, it is the gamma rays. Um, so we're going to look at the next part, which we're going to look at. It's the continuous spectrum and the line spectrum. So we're going to start with the continuous spectrum. I'm going to first introduce it with an example. Okay, so you have a prism. Okay, so let's imagine this is a prism. Okay, so this is our prism, and this is light. Okay, so and this is our prism. So what do you think happens when the light passes through the prism? Okay, so when the light passes through the prism, light splits into its components. Okay, so like red, green, it forms a band. Okay, band of colors, different colors and different wavelengths. Okay, so that's how it splits. Okay, so this is known as a continuous spectrum because it's uh it forms a continuous band of colors. Okay, it does not there are no spaces in between the bands because it's continuous. Okay, I get you understand now. So um, um so why does light split? Okay, why does light split when it passes through a prism? Do you remember that light contains different colors? Light, it is a mixture of different colors. Okay, and these colors have different wavelengths. Okay. So each wavelength uh, bends differently uh, when it passes through the prism. Okay, that's why they bend at different angles and lengths. Okay, so um, the one with the lowest wavelength, the highest wavelength, uh, bends less. Okay, I guess you get the idea. So it's because of the wavelengths. There are different wavelengths that they separate. Okay, if they all at the same wavelength, they would not separate. They would just pass through the prism, and mm, nothing would change. Okay, so that's the continuous spectrum. Okay, continuous, no spaces in between the colors, and so on. And now, what is line spectrum? So a line spectrum. So you have a prism. It's an example. Okay, prism. So a line spectrum deals with heated gases. Okay, so let's say you have heated gases. Okay? Heated gas. So heated gas. You have heated gas here. So when this heated gas passes through um, this this prism, so it forms uh, lines. Okay, so lines. So there are spaces in between. So this is a space. This is a space in between. It is not continuous. Okay? So line spectrum are produced by gases or heated gases. Okay, so we get distinct colored line. Okay, so it is also known as atomic emission spectrum. It's only produced by gases. Okay, so what are the differences between um, continuous spectrum and uh, uh, line spectrum? So continuous spectrum deals with light. So continuous spectrum, let me, spectrum deals with light, while line spectrum deals with heated gases. Heated gases, okay. And the other one which you can add by yourself is that uh, in continuous spectrum, the bands of colors are continuous, okay. There are no spaces in between the colors, so they are all mixed. No, when one color ends, another color starts forms, okay. So that's the difference.